One of the absolutely critical concepts in calculus is the idea of rates of change. So we can talk about average velocity versus instantaneous velocity. Remember, velocity is just the rate of change of the position of something. So the average velocity is just the change in distance divided by the change in time. There's no calculus involved there. It's how much has the distance changed divided by how much has the time changed. Alright, so that is average velocity. When we talk about derivatives, what we're talking about is instantaneous velocity, or instantaneous rates of change. So we start with s of t, we call that the position function, and the velocity is the derivative of the position function. So the velocity is the instantaneous rate of change of the position. We designate the initial position and the initial velocity as s sub 0 and v sub 0, sometimes s naught, v naught. So we're talking about objects in free fall. The position function looks like this. If we're talking about free fall, neglecting air resistance and near the surface of the Earth, we use the position function of negative 16 t squared plus v sub 0 t plus s sub 0. Again, where v sub 0 is the initial velocity and s sub 0 is the initial position. So in order to get the velocity function from that, we can take the derivative of this position function. So we do that, we take the exponent of t, bring it down here, multiply it by the negative 16, so we get negative 32. We got t, we reduce the exponent by 1, so it was 2, now it's an exponent of 1, and then the derivative of a constant times t is just that constant, v sub 0. Note here that we're taking the derivative with respect to t, since t is the independent variable here. And just note on the wording of problems, if we drop an object, we can consider that initial velocity to be 0. So a common type of problem we'll see is right here. A projectile is shot upward from the Earth's surface with an initial velocity of 384 feet per second. What is the velocity after 5 seconds? So we want velocity. We're going to start off with the position function. The position function, negative 16t squared plus the initial velocity times time plus the initial position. Since they told us that it's shot upward from the Earth's surface, we're going to consider the initial position to be 0, right at the Earth's surface. To get the velocity function, we take the derivative of that position function. So again, we have negative 32t plus 384. And if I want to know the velocity at 5 seconds, I just substitute 5 into that velocity function and I can get 224 feet per second. So that is the instantaneous rate of change of the position at t equals 5 seconds. That's the velocity. If we're talking about average velocity as opposed to instantaneous velocity that we found here, we want to know average velocity, we have to have an interval. Here we want to know the average velocity between t equals 1 and t equals 5. This really isn't a calculus problem. We're just trying to find the difference in the position divided by the difference in the time. So the position at time 5, we can substitute 5 into the position function. When we do that, we get 1520. The position at time 1, substitute that into the position function, we get 368. And of course the time is 5 minus 1, so the amount of time that's expired here is 4 seconds. When we do this subtraction and then the division, we get the average velocity is 288 feet per second between t equals 1 and t equals 5.